This is an AIPMT question from electric charges and fields. It says two positive ions each carrying a charge q are separated by a distance d. F is the force of repulsion between the ions. Number of the electrons missing from each of the ion will be is how much, right? So if you try to understand what is given for you, he is saying that there are two charges q and q. They are separated by a certain distance d. Both are ions, that means both are positive charges. How they got that positive charge? Because they have taken some of the electrons from a neutral body away, so that they became positive ions. So between these two positive ions there is a force of attraction. According to Coulomb's inverse square law, that force is 1 by 4 pi epsilon naught q1 q2 by d square, right? So but he is asking what is that charge that it has. So this became positive, this q became positive because it has taken some of the electrons away from it, right? How many electrons? It became this much of the positive, as much of the electrons that is removed from it, right? So what we can say, q is positive as certain amount of negative charges are removed from neutral. So q is as much positive as much the number of the electrons that are removed from it, right? That implies q, positive charge, could be expressed as charge is quantized and into charge of electron or charge of proton, because both are same, where n is number of protons, excess protons that it has, that is number of excess electrons that are removed. As that are removed, this became that much positive. So in the place of q I can write Ne. So what happens to my equation? What happens to that equation? F becomes 1 by 4 pi epsilon naught. Q means Ne by r square. So F equal to 1 by 4 pi epsilon naught n square E square by r square. That implies n square equal to F 4 pi epsilon naught r square by E square. That means n equal to, under the square root, F 4 pi epsilon naught r square by E square. That's the answer for the problem. R is being called as D in the problem, so in the place of R I can write D square. So F 4 pi epsilon naught d square by E square under square root. Option C is the answer for the problem, right? That's how we solve the problem. Thank you for watching. This is again a very basic law, Coulomb's inverse square law itself. Thank you for watching.